Hi, Ash. All right. What are we doing today? Oh, getting efficient. Okay. First things first. I talked about it in the notes we wrote about the algorithm here, uh, but I didn't actually put it when we wrote the algorithm. So, uh, terminating condition if our index, in other words, the length of those two lists, if we're at the end, we return zero, or if big W is equal to zero. So, in other words, no capacity. That's it. We can return zero. So that's going to make it a little more efficient right there. And why is that? Let's see. If we go back to a drawing, yes, here we are. Uh, do do do. See the orange circled one. Uh, Okay, so we only have three items, but pretend there were more. So we were going to go down another level and more levels. But this one, this capacity, the big W, is down to zero. So even if there were more items, this branch of the tree is done because it will return zero here and it can start backfilling as soon as this one catches up. And so that's a nice thing. Because as you know, this tree can get out of control real fast. So, zoink. Um, we got that. Did I save it? Yeah. Okay. Oh, and I didn't talk about the knapsack. Where does this fall in the world of algorithms? It's a type called integer optimization, which falls under linear programming. So it's used for like scheduling work crews, or there's a lot of uses in economics, or finding the best flow through a network, whether it's a packet through a computer network or network in the broader sense, getting through it. It it's important. um, so let's get efficient. All right. Oh, but first we need to make some data because right now we've got three items in our list. And I keep telling you it's not efficient, but it runs fast. Let's see, is it running? Python. So let's check if I haven't messed anything up. No. Python knapsack. Oh, hey, I was playing around with this data, but we're actually going to create it, so I'm going to delete this. Okay, yeah. Okay. Yeah, still working. Three items, works fast, but let's make data. So let's make a new file. Uh, we'll call it create data. And I won't get too much into how we're doing this because it'll open up a whole other can of worms, but I'll explain things as I go. We're just going to make some random data and write it to a file, and then we'll read it back in our knapsack program. Uh, so there you go. And we will, let's see, so we're going to be using random data. So in Python, it has random functions, but you need to import random. But since we're only going to use one function from the random library, something you can do, so we're going to use randint. So to use it right now, we'd have to type random.randint. There it is. And I'm lazy. I don't want to do all that typing. So I can say from random import randint. And now I only have to just type randint to use it. I know, isn't that great? So we're going to open a file to write to it. Doesn't need to exist. It'll create it if it doesn't. And the way to open a file in Python is open. And we will assign it to a variable. So say f will be a variable, f equals open, then the file name, we'll call it nap data. And if you don't provide a second parameter, it will open for reading by default. But we want to open this to write to it, so we just put the string w for write. and then colon, start a new code block. Oh, nope, no, not, that's some, I got ahead of myself. So that would open the file, and then when we're done with it, we will have to do file.close. People forget that a lot. And in our little program, it would probably be okay, but it's not guaranteed to be okay. And if you're doing a lot of stuff with the file, especially if you forgot to close it and then you try to open it again, this can cause problems. So always good to close your files, and so much so that there is a better way to work with files. And I'll just say the open function that we're using was written, the Python people who wrote it made it usable with a Python keyword called with. And when something's written to be used with, it means it provides some kind of help to the programmer. So I will show you if we type with open, I'm just going to copy this because it's the same. Now, we haven't been able to assign it to a variable name yet, but the way we do that with is as f. And then we start a code block. So forget this. We're not going to use that. The help that it gives us is when we come out of this code block, it will automatically close the file for us. So we don't have to worry about remembering to close it. So we are going to, now we're going to make some random values. Let's assign to integers. How about we'll have a new weight equals rand int. Weights, how about we go 1 to 100. A new value equals rand int. Values we can do 1 to 1,000 just to be different. Random, so this will give us a random number from 1 through 100. I just want to point out, usually in Python, when you have a range like this, it will be inclusive of the first one, but exclusive of the last one. But random gotta be different. It's inclusive of both. So this truly will be 1 through 100 and 1 through 1,000. So. But we want to do this, and then we're going to write it to our file, but we want to keep doing this for however many data items we want. So we need a loop. And yes, we could use recursion to loop through it, but not this time. we want to get this done fast. So the number of items, we'll give it a variable name, and we'll start with 200. And for our loop, we need an index variable. So we'll say I, and then we're going to say while is a nice way to do a loop, a while loop. While I is less than num items, do what's in this code block. So we have a new weight, we have a new value. Now let's write it to the file. So that's f.write. And we go, so we have our new weight. But what we want to do is we want to make a string that's number space, weight space, value space, weight space, value, until we're done. How do we do that in Python? We want to make a string, but we want to drop the value. We don't want the word new weight. We want what new weight is equal to. We can do that in Python with an f string. We just put an f before the opening quotes, and now we can put variable names or actual Python code in curly brackets, and it will get resolved. So the weight space, more curly brackets, new value, and then we're gonna, and I don't know how to spell, And then we're going to put another space because right after, it's going to keep going through this loop. So, then it'll write the value, this new weight right after it, blah, blah, blah. Okay. And then, very important, we need to remember to increase our index. So I plus equals 1. And I think we mentioned this, that plus equals is a shortcut for I equals I plus 1. Okay, that should work. So this should create this new file, and it should be full of weights and values. Let's run it. Python and create data. Ooh. And you can see over here, it created, now, ooh, you know what? Well, especially, I'm so used to things having an extension on them, files. Let's call it netdata.txt, just so we remember it's a text file. So we can delete this one. Yeah, just go away. And we'll just run it again. There it is. All right, take a peek at it. Yeah, looks like it's got a bunch of numbers separated by spaces. Perfect. All right, now back to Knapsack. So instead of using this, all right, we will rewrite this. Forget rewriting it. First, we'll comment that out, and we need to read in the data. I forgot about that. So let's make some empty lists to read into. You can call them whatever you want. How about wait list? Not that kind of wait list. And we'll just make it an empty list. And value list. Again, empty list. And now, let's open that file again. This time we'll open it for reading. So with open nap data.txt as f, start the code block. And you'll see we didn't give a second parameter here. Last time we did the W, that was for writing. This time we're reading, which is the default. We could put R, or we could just leave it out, and R is the default. So it's nice. And what are we going to do? We are going to read, we're just going to read it all, the whole file as a big string. So just a raw string, we can call it raw data equals f.read. No parameters on that function. And it's just going to read it all in. So now we got a big old string. So, but, you know what? So this will be a string, right, when we read it. Strings contain a function called split. So we could say dot split. And you can then give it a character or a string to split on. If it was commas, you could put a comma. But by default, it splits on white space, which was what we've done. We put a space in between each string, so we don't have to put anything because the default is just what we want. So now raw data and split will produce a list of those numbers. So the raw data is a list. But we need to be careful because they're not really numbers. They're still strings. They just have numeric characters in them. Like if one of them was 1, 2, 3, it's not the number 123. It's just the letters 1, 2, 3. But we're gonna remember to change that. The int function in Python can convert a string with numbers into an actual number. So don't worry. All right. Now, we're going to loop through that list. And a really easy way to loop through a list, I know that first exercise where we added all the items in a list using recursion. This time we're just going to do it the easy way. So we have our list raw data, So you can say for item in raw data. Start the code block, and then we can start it. So the first time through, it'll be item 0, then item 1. But and you'll see why soon, we also want to know what index number the item is. So to do that, use a function called enumerate, and you apply that to the list. And that will spit back out not just the item, but the first thing will be the index. And so we can do this. And what it gives us back is something called a tuple. This is sort of like a list, but it's immutable, meaning you cannot add things to it. You can't change it. You can't delete items from it. And so you could tell it's a tuple because there's nothing around it, and sometimes you have to do this, you could put it in parentheses. That's also a tuple. But typically when you put it in a for loop, you just put nothing around it. It knows it's a tuple. Very common. So now we have the index of the item and the item itself. So you'll see why we wanted that index in a second. So let's start adding to our list. So we have wait list. And to add an item to a list, it has an append function, so dot append. And we will append, remember, not the item, but first we use the int function on the item, and that will convert it. Now say item was not numeric characters, it was like the word hello, and this would freak out and throw an error, but we know we're good. It's all numbers. But we only want to add to the wait list for the even numbered numbers, the even indexes, the index 0, index 2, because remember we wrote wait value. So what you can do is, in Python, remember we had if, and you can do if this, else do this. If there's only one thing after the if and one thing after the else, you can actually condense it into one line where after what should happen with the if, you can actually put the word if after. So do this if I modulus 2. You seen modulus before? I'll explain it. This means divide I by 2 and give me the remainder. So if that remainder is 0, we got to have an even number, because an even number divided by 2 always has a remainder of 0. So do this if this is true, else do this. And then I'm going to copy and paste because all we have to do is change the word wait to value. So do this if it's an even index, otherwise do this. And we're filling up our list. And then we will, now let's run, we will run, I'm going to copy that. But instead of using those little lists, we will use the new list that we just made, wait list, value list, and then we can keep the capacity the same, 50. So there won't be a lot of items in there, but well, it'll be a nice challenging problem for the computer. So let's see how that runs. So if you hit the up arrow, it'll keep going up in your history of things you've typed into your terminal. So you can go back to when we ran the knapsack, and I'll hit enter, and it's going, and it's going. Ooh, it's taken a while. I didn't even think it would take this long. How big do we make Yeah, we only made 200 items. Oh, finally. All right. So wow, just 200 items, and look how long for a freaking powerful computer to calculate that. That's not good. So, I mean, just imagine if we put like 500, which still is not a lot of items. I mean, you'd be here all day. So, didn't mean to hit that. Let's fix this. So, all right, we need a picture. Yoink. So here is our tree, but let's look at another one I've made. A very boring one. All the weights are one, all the values are one, but there are four, wow, 4 items. But as you can see, I didn't even bother drawing the I equals 3 line because already I equals 2, there's 8 ovals. So for I equals 3, there'd be 16. And yeah, wait a minute. Hey, ain't nobody got time for that lady. What do you have to say to that?
Ain't nobody got time for that.
Nice. So, but notice what I've circled. So, you know what? Don't notice that yet. Remember we had our original, where was that? Oh yeah, here I took a picture of it. When we were just going through the list, adding up the items in a list, we could identify which run through the function it was by this iterator. This was the first run through, the second, but yoink, we can't do that here because I equals 0, there's 2 things, I equals 1, there's 4. I mean, so just knowing the index isn't enough to identify a function run through. What else we got? So the index changes. What else changes? Let's look at the function we wrote. What else changes and run the... Oh, look at that. Well, well, well. So the index changes, and another thing that can change is the remaining capacity. So, wink. And just not to get too deep into it, that is, so with our little adding up the items in a list, the class of how long it will take is the size of the list. In computer science we call that big O n. We're dealing with n items, big O meaning the average run time. I think there's more to it than that, but I don't want to get into it. But say you had the list, and then for each item in the list you had to run through the list again. That would be big O n squared. There could be the big O log n, big O n log n. The worst is if it's something to the n. That's terrible. But for the knapsack problem, turns out it's big O n times big W, the number of items in the list times that initial capacity. So, all right, that was an aside. But it also, we can identify a function run through by the index and the big W value. Big W, remember, being the remaining capacity in the knapsack. So here you see I've circled 2 items that both have an index of 2 and they both have a big W of 1. And we can do something called memoization, where every time we're about to run through the function, we're going to say, hey, have we done this before? Have we done one with the same I and the same big W? And if not, we're going to run it and we're going to save off the value we get. This will be a big time saver because in our little example, I've circled 2 that are the same, but as we've talked about, these rows get unbelievably long and there will be lots of duplicates no matter what the data. So let's get rid of this. Yoink. And let's start memoizing. So there's different ways we could we need a way to store what we the function run throughs that we've done. And remember we said we can identify a run by the index value and the big W value. So how do we do that? Well, we can use a dictionary. Dictionaries are built into Python, and other languages have them, but most languages call them hash maps. Don't want to get too deep into it, but that's because a dictionary has a key and a value. And you can tell the dictionary, hey, give me the value that has the following key, and it will look it up really fast, almost instantaneously. And it does that because no matter what the key is, no matter how complicated the key is, it will take a hash value. Hash value is a way of getting a numeric value from something that's typically not a numeric value. And I'll just leave it at that for now. But only to say that the key, of course, has to be what we call hashable. And that'll come up soon. I'll show you. But if we're down in our terminal, if we just type Python, we get the Python interpreter. And I can just to show you what a dictionary is like, we can call it D equals, and we can make an empty dictionary with the curly braces. So now D is an empty dictionary. And then we can add things to it. Say D, and then we use, just like when we index into a list, we use those square brackets. It's the same thing with the dictionary, but inside these square brackets we put a key value. So I'm going to say D in our dictionary with a key of A that will have the value of 5. Whoopity-doo. So let's look at it. Look at it. All right, well, let's make another one. So D with the key value of B will be equal to 7. Now let's look at D. You can see it's key colon value and then a comma, and then you get the next key value. Okay, so, and if we want to say, okay, my dictionary, hey, remind me what key, with the key of A, what value does it have? Oh, 5, thank you, okay. And you could also do that, another way is dot get, and you could give it, B, 7, thanks. A big difference here is, let's say we're searching for something, a key that doesn't exist. If I use this method, let's use C for the key. And it could be, doesn't have to be just a letter, it could be any word, anything. Hello, there is no key, hello. And it will give us an error. But if we use the get function, not G, d.get hello, and I need to put ending quotes. It won't throw an error, it just doesn't, it actually returns a value in Python called none. So it returns none. And that's a big difference. Now the get function also allows us, though, if we provide it a second parameter, that's a default value. So if it doesn't find the key, it will return the default value. We could say like unknown, the string unknown. That's cool. Okay, and to quit the interpreter, we type quit. It's a function, so no parameters. Ta-da! And so, where were we? We were memoizing. So we need everything in our function to be able to access this dictionary. So we could create it outside the function up here. The Python's top down, so yeah, in order for things in here to see this variable, it has to be above it where we create it. Or another way, we could pass it in, or not. We could use our default So just like we have I equals 0 as the default parameter, we can have a parameter memo, and if you don't provide a value, it'll just be an empty dictionary. So we just have to remember that we need to pass memo every time we call this function. Otherwise, it will use the empty dictionary, which we don't want it to do. Okay, so there's that. Now let's work with memo. So after we check for the terminating condition, we should check if we've been here before, if we've done a function run through with the same I and the same W. So we're going to make a tuple. We talked about a tuple before, I believe. So if, now we'll say a tuple of I and big W. So the index and the remaining capacity. So that tuple is in memo, which this means in Python is if you use in and then you give it a dictionary, it means if this exists as a key in this dictionary. So if that's true, then all we want to do is return the value in the dictionary that that key is associated with. So if it's there, just return memo, and we'll give it this tuple of I and big W. And that's that. Now the only other change we have to make is, okay, so now if we've fallen through, if this is not true, then we know that memo does not contain that key. So we'll need to write it. So if this is true, then this is going to be the value we put in the memo. So instead, let's just assign it memo I big W equals this. So we've saved it off, we've memoized it, and then we'll return this value that we just saved off. And we can do the same thing here. In fact, I'm just going to copy and paste it. We're going to memoize this value and then return that same value. All right. And that looks pretty darn good. So let's try running it. Python, not the data, Knapsack py. Okay, yep. Oh, and look how much faster it ran. You know what? I'm pretty confident though. I think we've really increased the speed. So let's do create data again, but instead of with 200 items, let's try 10,000. 10, 1, 2, 3. So let's rerun Python create data. Boom. So now we've got 10,000 items. We can take a peek at it. Oh my goodness. There's a lot in there. So now let's go back to Knapsack and we're going to run Knapsack again. Let's see. There's a problem. Python has a limit, a built-in limit of how many times it will recurse through a function. And that's a safety precaution, you know, so things, if you make a mistake and you don't have a terminating condition or something, things don't get out of control. But we know what we're doing. And as we talked about before, the maximum number of times we will run through this function is the length of the list times the initial capacity. So there is a way to increase how many times you can recurse through a function, you know, as you how we built that tree, you know, it runs through so many times. So we need to increase that value. So we need to use a library. So we will import sys, doing a system type change here. And if you say you didn't know, I mean, how did I find this out? I just Googled it. So, and then before we run our knapsack algorithm, and I wrote it down somewhere. I always forget. Ah, yes, it's sys dot set recursion limit, and as a parameter it will take our new recursion limit. So I'll just say the length of wait list times our initial capacity. You know what? I hate that we're just writing 50 here. Let's make that a variable name. We'll say initial, like lowercase, initial capacity equals 50. And we'll change this to initial capacity. And here we'll put initial capacity. So that should fix it. We're going to save it. Let's run it again. Oh, look at that. 10,000 items, and it did it really fast. So that's pretty awesome. So we memoized. Look at us. And we made our knapsack function really fast. So have a great day. Bye.